The first decision you need to take is which installation variant to use. EIB KNX devices are available as twisted pair devices, which are installed with a separate data line, but also as power line devices which utilize the conventional 230 volt mains network for data transmissions. Radio controlled equipment is also available. Twisted pair is the installation of choice for a new house. These devices represent the most cost-effective solution. In a new house, it is generally not a problem to install the additional data line. Therefore, we will use twisted pair as our sample installation variant in the example which follows. The lighting control in the living room of the customer could then look as shown below. Only one switch and two rockers is needed to operate the two functions of lighting and shutter and blind control. As the functions are implemented by means of EIB KNX, the system can also be operated from other points, which means in this case that the required function of being able to switch off all the lights in the house together can be implemented from a central location. Mechanical opening and closing of a blind via a timer or sun sensor is also no problem. In order to be able to plan an EIB KNX installation properly, you first need to know what it is exactly that the customer wants. However, in contrast to a conventional installation, there are two different alternatives for building wiring for an EIB KNX system. The first option is to use built-in EIB KNX devices directly at the location of the consumers and in the switch sockets. The second option is the installation of series devices in corresponding distribution or sub-distribution layouts. From there, the cables are fed in a star arrangement to the consumers. The use of sub-distribution layouts makes the units more easily accessible. It is also possible to combine both installation variants for the EIB KNX devices with ease. In our example, the easiest task of our customer's lighting control system is to switch a single lamp on or off. Only a handful of components are required in order to implement this with EIB KNX. You can have a look at the required components now. Many EIB KNX devices are designed as modular DIN rail components. In the distribution board, they are snapped onto a DIN rail. The power supply unit is the first bus device that is snapped onto the rail. It supplies a DC voltage of 28 volts. The actual load switches are called switching actuators or binary outputs. They are available as single-channel or multi-channel switches, for example, with two potential-free make contacts. This actuator is able to switch 230 volt consumers up to 6 amps. A screened twisted wire pair serves as a bus line. All EIB KNX devices can be connected to line. Push buttons are composed of a universal flush-mounted bus coupling unit and an application unit, which is also called an application module. Both devices have to be from the same manufacturer. The push button is connected to the bus coupling unit. The connection is established by a 10-pin contact strip, which is also called a physical external interface, in short PEI. What remains is the connection of a power supply unit and a load switch to the main side. The consumer is connected to the load switch. The hardware is ready to operate. All bus devices are programmed by means of a PC, so now you can test the system's functions. The keys of the push buttons have a neutral central position from which they can be easily activated. Now the sensor transmits electrical signals across the bus. These signals are also called telegrams. The actuator reacts to this command and accordingly switches the light on or off. When configuring an EIB KNX system, it is particularly important to take into account the bus-specific limits for cable lengths and the guidelines in terms of topology. The maximum permissible cable length between power supply and bus device is 350 meters. The total bus cable length is 1000 meters. At most, one additional power supply unit may be connected to the bus. When configuring an EIB KNX system, it is particularly important to take into account the bus-specific limits for cable lengths and the guidelines in terms of topology. The maximum permissible cable length between power supply and bus device is 350 meters. The total bus cable length is 1000 meters. At most, one additional power supply unit may be connected to the bus. A minimum distance of 200 meters between the two power supplies must be observed. One line, i.e. a maximum of 64 EIB KNX bus users, can be configured with the ETS3 starter. Larger systems will need further lines which are covered by the same rules. However, these upgrades need to be configured with the ETS3 Professional. Certified training centers offer ETS3 professional training. Via a main line, up to 15 bus lines can be connected. All lines together are called an area. Special line couplers connect the secondary line to the main line. For most projects, this expansion level is sufficient, but in larger projects, up to 15 areas can be connected via backbone couplers and backbone lines. During specification, the EIB was defined so that the bus could operate with only a single wire pair. This wire pair has two functions. It supplies a DC voltage of 28 volts to the bus devices. At the same time, data can be transmitted over this wire pair. The telegrams are modulated on the DC voltage. Although bus technology is applied, the use of power current, which is still responsible for the main part of the electrical work, is necessary. The power current is switched, for example, by actuators in the distributor comparable with remote-controlled relays. In principle, the wiring is very simple and well structured. Please test the functions and click on the sensor fields. The commissioning of bus users is performed by means of a PC and a series or built-in interface in USB or RS-232 design. As one of the last steps, the functions requested by the customer are taken into operation. You can also find out more about this in the ETS3 Starter Learning Program on this CD. Now, the project can be commissioned, which in practice can last a longer time. After programming the bus coupling unit takes over its previous functions again. Each bus device is equipped with a universal bus coupler, which receives its current function during programming. The most commonly used type is the flush-mounted bus coupler, which is normally designed for screw fixing. Bus couplers are also installed in so-called push-button interfaces that serve as a connection for conventional switching contacts. Built-in devices can be installed in suspended ceilings or parapet channels. They are also equipped with a bus coupling unit. The function of each built-in series unit is based on a bus coupling unit. Here, for example, you can see a logic device. The range of EIB devices is very large, but in principle, the devices can be divided into three categories. Tactile sensors are the most commonly used sensors. They offer a multitude of functions and can, for example, be used to operate lighting, shutters and blinds, central controllers, and group controllers. As an operating element, a tactile sensor is made up of two parts. It comprises the tactile sensor and a built-in bus coupler. Motion detectors are also a familiar type of sensor. Other types of sensor include, for example, room temperature controllers, displays and binary inputs. Individual room temperature control helps to maximize efficient use of energy and also helps to provide a high level of comfort in your living space. Display units inform the user, for example, on leaving the house where the windows and doors are closed. Via such binary inputs, conventional switch contacts, for example window contacts, can be connected. According to their design, the contacts are driven by a voltage or by potential free contacts. Actuators are used to switch electric consumers. They vary in terms of the number of outputs. In the type of consumers they operate and their functions, such as switching, dimming, heating controls, or blind controls. Actuators are used to switch electrical consumers. This actuator is suitable for blind drives. It switches the load current of the motor. The actuator mainly controls lamps and sockets. The switching of lighting is the most commonly used function of actuators. Heating actuators, which are especially parameterized for this function, are also available. Whether underfloor heating, radiators, window contacts, or automatic flushing systems, all performance influencing factors can be considered. The system components of an EIB KNX system also include a power supply with integrated choke, which is available in various performance sizes. It is short-circuit proof and current limited on the bus side. The ETS3 requires a built-in or series PC interface for programming and diagnostics. It is available as an RS-232 or USB interface. To be able to communicate with the EIB, the ETS3 requires a serial interface that is available as a flush-mounted or DIN rail-mounted bus device. If the notebook is not equipped with an RS-232 interface, a serial PC MCIA card is the solution. Especially when installing bus systems such as LCD mini panels or telephone systems that are still equipped with older bus devices, a serial PC interface is required. Since it is necessary that the ETS3 software can also be installed on modern notebooks, the access to the bus is supported via a USB interface. Basically, there are two different ways in which the actuators can be installed. First, the actuators are located in a distributor. The wiring to the individual consumers is laid star-shaped. This solution requires a relatively high amount of cabling and bigger distributors. However, there are also some advantages. Secondly, if possible, the actuators should be installed close to the consumers. For this reason, actuators are available as flush-mounted devices, surface-mounted devices, or installation devices for suspended ceilings. In practice, the distributed installation is preferred. It has the following advantages. The power supply unit has to be earthed via a green-yellow coloured conductor. Static charges of the bus cable can then be avoided. According to the German standard DIN VDE 0100, the following limiting values apply to safety extra low voltage. The safety extra low voltage circuits do not require insulation on the user's side. A basic insulation to earth is sufficient. A safe insulation of the power supply system and other networks must be guaranteed. This also applies to other networks. EIB KNX certified or EIB KNX approved cables are recommended for use as the bus cables. When installing mains and bus cables, 4 different types of installation must be distinguished. First, mains cables and bus cables may be laid directly next to each other, provided that both cables are sheathed. Second, isolated single cores of a mains cable may be installed directly next to the sheathed bus cable. Third, the minimum distance between isolated single cores of the bus cable and a sheathed mains cable must be 4 mm. Fourth, between isolated single cores, a minimum clearance space of 4 mm must be observed. To also meet these requirements in distributors, the sheeting of the bus cable may be removed only shortly before the terminal. Devices with higher power losses should be positioned in the upper area of the hub. In order to increase the clarity of the layout, we recommend arranging bus users and conventional high voltage current devices in separate fields. When planning the installation, the required mounting space must be calculated. Here, the following standard values are valid. One DIN rail is subdivided into 12 units, whereas the width of one unit is 18 mm. The mounting space of EIB devices can be calculated by means of a formula. If you divide the number of all consumers by the factor 8.5, you get the number of all required DIN rails. Consumers are, for example, lamps, switching sockets, blind motors and heating valves. As EIB devices are only designed for a maximum environmental temperature of 45 degrees, lossy mains devices should not be installed next to the bus devices. When installing the installation of a bus system, it must be remembered there are only a few EIB specifications that should be applied. Even the arrangement of the bus devices may be mixed with mains devices. Here, isolated areas are not required. But in practice, often one of the basic requirements is not fulfilled. The bus cable in the distribution board must be sheathed, because the EIB is part of the self circuit. Unused parts of a data rail must be protected by cover strips. In this way, no accidental contact to the mains core occurs, and this normally would damage all EIB KNX devices of a line. Data buses offer an alternative means of connecting the bus users in the hub. With these data buses, the connections are made automatically when the series devices are snapped in place. To protect the data rail from pollution or accidental contact with other circuits, it is covered by a data rail cover. The branching of bus cables and mains cables in a common box is not allowed. Such a wiring may only be used in junction boxes with a partition. Bus coupling units require boxes with a depth of 50 mm. If bus devices and power devices are installed under one cover, the person's safety on the main side must remain guaranteed when removing the cover. In some cases, the installation requirements of the device manufacturer must be observed. The bus connection block is a very important component. The EIB only uses this type of connection block. In the following, the use of the bus terminal is explained. The bus connection block consists of two parts. Up to 4 bus wires can be connected to each part, but before connecting them, 6 mm of the wires have to be stripped. The guiding also serves as a mechanical protection against incorrect polarity. The bus connection block allows the removal of bus devices without interrupting the bus. Bus cables may only end at the device itself or at the bus connection block. The incorrect installation of the bus connection block leads to a polarity reversal. The bus line may be laid in any tree structure. The line can be branched where it is necessary. There are no terminating resistors. If the building is equipped with a lightning protection system, the bus cable of a building crossing installation must be integrated into the lightning protection plan. Here you see the first installation type. At the entrance of the building, a lightning current arrestor must be connected to the bus cable. The first bus device in the building has to be connected to a special blue overvoltage arrestor terminal for secondary protection. In the following, this terminal is described in more detail. The distance between lightning arrestor and this terminal should be a few meters. Here you see the second installation type. If the building crossing bus cable is installed in a metal conduit and earthed at both ends, the installation of lightning arrestors is no longer necessary. Only in EIB KNX installations is this type of overvoltage arrestor terminal compatible. Its function is to limit the overvoltage to the value of 2 kilovolts. The green-yellow conductor in the middle is connected to the nearest earthing point. The other 2 wires are directly connected to the bus. At this terminal, the bus cannot be branched. The protective earth conductor of the distribution board must be connected via an earth-free terminal, as the DIN rail of an EIB KNX installation cannot be used for earthing. The figure shows the 2 terminals of an actuator. As both cables i.e. bus and mains cable, surround a relatively large surface, outer interferences can induce very high voltages in this big induction loop. All ends of the bus cables should be clearly marked, which is very important when different bus cables are installed together in one distribution board. The compatibility between the installed cables and the EIB KNX installations must be checked. Each cable must end at a bus terminal. As the EIB operates as a self-circuit, the isolation resistance of the bus cable should be measured. All overvoltage arrestor terminals must be removed before carrying out the test. The test results should be added to the documents of the EIB installation. When running a visual check, the isolation of the EIB KNX network and other networks must be tested. Also, in distribution boards, the installed bus cable must be sheathed. All bus devices should be clearly identified by marking them with the complete physical address. This also applies to flush-mounted devices, built-in devices and distribution components. It must be ensured that the marking complies with the actual point of installation. A visual check must be done to ensure that all EIB KNX power supplies are connected to the protective earth conductor. A minimum clearance space between insulated wire cords of mains cables and those of EIB cables must be observed. For this reason, the unused sections of a data rail should be covered by a data rail cover. All installed bus cables in the distribution board must be sheathed as well. The endings of the shieldings must not be earthed. According to the regulations, all special overvoltage protection measures must be taken into account when installing a building crossing EIB system. Here you see the structure of a correctly installed bus system. Bus cables from different lines may never be linked together, as the following example shows. As all lines are galvanically isolated from each other, the inadmissible connection between two lines can be checked by a simple measurement. This check must be carried out, as incorrect wiring does not always cause a functional error. The ETS topology view can be used to make sure that the current number of bus devices does not exceed the maximum admissible number of 64 bus devices. Control valves that are connected to the line count twice because their power consumption is higher. Even if the maximum number of bus devices is connected to the bus line, the supply voltage must be sufficiently high, up to the last connected bus device. For this reason, the voltage must be measured at both ends of the bus line using a multimeter. At the end, there are still some basic requirements left which are often ignored. It must be checked, for example, if the cables are installed so that the creation of induction loops can be prevented and bus devices are not damaged. The practice shows that some EIB installations are equipped with devices that were not certified. Such devices are considered to be a risk factor for the installation, and therefore should be accurately checked. But what has this abandoned dog to do with our check? It's very simple. The EIB KNX installation should not be equipped with devices that are not programmed. If an additional line coupler is necessary for a later expansion of the bus, it must be programmed together with all the other devices of the system according to its special requirements.